Since early 2026, artificial intelligence regulation has shifted to strict enforcement. Operators must treat AI models strictly as regulated financial infrastructure. Software experimentation is over. The European Union AI Act imposes mandatory financial penalties for non-compliance. This image shows the European Parliament Assembly Hall. The governing body set a strict €35 million baseline fine. The secondary penalty threshold scales aggressively. Enterprises face exposure to fines reaching 7% of global turnover. This image shows the Sansad Bhavan in New Delhi. Regional vectors like the India Digital Personal Data Protection Act enforce equally rigid mandates. This regulatory shift immediately impacts corporate compliance budgets. Baseline compliance costs face a mandatory 40% increase. Executive boards routinely fail to budget for rigid compliance automation. We deployed AI as standard software. This guarantees a failed audit. Compliance failures bleed capital. They stall enterprise deployments entirely. We must map the origin of this technical debt. Executive boards demand aggressive quarterly deployment targets. Frontline operators deploy unlogged models strictly to meet these demands. Consider a specific failure scenario. A production model rejects an external vendor invoice at 2 in the morning. An external auditor arrives weeks later. They demand the deterministic logic for that exact rejection. A mechanical breakdown occurs during the audit. The deployment engineer stares at a shifting weight matrix. The data is lost. Training weights overwrite constantly. Data provenance evaporates to reduce server costs. We would never build a chemical pipeline without physical pressure gauges. Yet we build massive data pipelines with zero internal telemetry. Undocumented shadow AI endpoints represent a catastrophic structural design flaw. The corrective measure requires a rigid operational shift. Operators must force auditability directly into the core inference loop. This diagram shows a matte gray blueprint of an inference loop. We must treat the API endpoint like a double-entry compliance ledger. The system must capture the exact input payload. The system must also capture the exact output payload. The system must hash the paired records. The system logs the hash in a cold storage vault with an exact timestamp. We must address engineering trade-offs directly. This telemetry introduces a latency penalty. It increases specific storage costs. We can validate this trade-off easily. Cold storage costs remain strictly lower than external audit fines. We must also shift our focus to external dependencies. Hyperscaler instability introduces massive organizational risk. Silent third-party updates threaten to alter core model behavior. We must identify fourth-party data exposure. Operators must document the underlying technologies processing enterprise data. A defensible internal baseline restores physical control over probabilistic networks. Strategic resilience requires immediate action. Enterprises cannot wait for federal regulatory certainty. This image displays our internal readiness checklist. First, verify vendor stability. Next, audit fourth-party dependencies. Finally, update contractual terms. We deploy the 48-hour null log blackout protocol. This protocol validates system readiness safely. We begin with the setup parameter. The operator must isolate a single low-risk internal AI microservice. Next is the execution parameter. The operator force routes exactly 1% of inference traffic through a strict logging wrapper. Finally, we define the measurement parameter. The operator measures the exact latency penalty. The physical pass threshold is strict. The system passes if it records the payloads with a latency penalty below 40 milliseconds. The system fails if it drops payloads under load. The frontline operators executed the mandates they received. Technology must restore operational agency to the engineers managing these systems. Rigorous, deterministic telemetry converts massive compliance threats into manageable engineering parameters.